Welcome today to group 22 for Computer Network TCN. Here's Yusuf, the leader of the group. You may continue watching the video. Thank you.
One, and I'll be explaining the IPv6 configuration for a network. I'll cover both static addressing and DHCP v6 dynamic configuration. I'll start with the code first. So first, we enable the IPv6 routing on the router, which allows it to forward IPv6 packets, just like how we enable IP routing for IPv4 here. And then we assigned IPv6 addresses to the router's interfaces, and each interface gets a global unicast address and a link local address for internal communication. Just so as here, that's the IPv6 address for the lab 2, and this is the link local for lab 2, and these ones are for lab 1. And then this allows the router to communicate within its subnet and with other networks. And then for the DHCP v6, we dynamically allocate them to devices in different subnets. So firstly, we created a DHCP pool. As you can see here, that's it for the lab 1, and that's the DHCP pool for lab 2. And then we defined the address range here and here. And then we assigned it to an interface. As you can see here, this one for lab 2 and this one for lab 1. So this setup ensures that client devices in lab 1 and lab 2 automatically receives IPv6 addresses, DNS settings, and domain names. And then we configured OSPF v3, the IPv6 version of OSPF, so our routers can share routing information here. And then this ensures the efficient routing between different network segments. And then we connected we connected the ISP. We configured the router that connects to the ISP, which gets a global IPv6 address and participates in OSPF v3 routing to forward packets to the internet. Here is the example. This one for lab 2, and this one for lab 1. So this step allows our network to access the internet using IPv6. And now I'll show you first the servers. We'll start with the FTP server. So this is the configuration for the FTP server. The IPv6 address is like this one. And then this is the subnet mask, which ensures the server has a unique and globally routable address. And then the link local address, which is automatically generated, and it is used for communication within the same local network. And the default gateway, which is the router's interface for the server subnet. And the DNS server, which is also set to its own IPv6 address for proper DNS resolution. I'll try the rest of the servers. Here's the DNS server. As you can see, that's the IPv6 address, so on. And this is the web server. Yeah, IPv6 address. And the ISP server. As you can see here, this is the IPv6 address. And then now I'll show you the PC configuration in the DHCP mode. Here, so this PC is configured, like all our PCs are configured to use automatic IPv6 addressing via DHCP. So as you can see here, it has been assigned the following IPv6 address, and yes, it's automatically assigned. I'll show you a couple more examples here. Yes, it's also automatically. The DNS server is also set. And let's check for lab 1. It's also automatic. Let's check another one. Okay. Automatic too. Another one. Automatic. One from lab 2. Check on another one. Automatic. And last one. That's automatic. Okay. So this setup eliminates the need for manual configuration, as the PC automatically retrieves its IPv6 address, default gateway, and the DNS settings. Okay, that's all for my part. Thank you.
I will be demonstrating how to verify network connectivity using the ping command in Cisco Packet Tracer. We will be testing connectivity between different devices in our IPv6 network setup. So let's begin. So at first we will start with lab 1. So we'll try to ping lab 1 and lab 2. So we'll pick PC 1 and go to desktop and command prompt, and we'll try to do ping. Now we'll try to do IP config first, so we can know what's IP address, so we can ping it later. We'll put it on top, and we will minimize it a little bit here. Okay, so now we'll go to the other PC. We'll go to PC number 25, and we'll go to the same thing, command prompt. We can just copy this one and we paste it here, and then here's the IP address. So just copy the IP address from here, copy. No, you have to actually click on it, copy, and then go to ping here, paste, and it should come positive. So was successful. So now let's ping PC1 from PC25 from lab 2. So let's now do this. Ping. Okay, now it should work as well. So let's see. Yeah, the ping was successful. So now we can close this and go to the other one. So next will be we'll try to ping from admin to management. So yeah, let's go to admin, the admin room. So just pick PC admin 1, doesn't matter, and then we'll put config desktop IP config as well. IP config. Now we know the IP address of this one. So let's go to the PC we're trying to ping. Now let's move on. We're going to try to ping the administrator from the admin room and vice versa as well. So we just pick PC1 here, and we're going to do the command prompt. We're going to write IP config. Now we have the IP address of this one. Make it top so it doesn't go anywhere. And then we go to the admin PC as well. And then we go to the program, to desktop here, command prompt, IP config. Yeah, so now we're just gonna ping, we're just gonna copy this IP address, and then we're gonna go here and ping it. It should be successful. Yeah, 0% loss, so it was a success. So now let's get the IP address from admin 1 here and try to ping it from this PC. So yeah, it should come up successful. Should be successful. Yeah, 0% loss. It was 100% correct. So now let's go to let's ping classroom. This one. Let's ping classroom from, let's see, PC administrator number 1. Let's see. So desktop. Gonna go to so IP config as always, so we can know the IP address. So I'm gonna put it on top, and then we're gonna go to the PC administrator, and then let's put this on top, and go to desktop, command IP config, and then we're gonna copy IP address from here, copy, and then we're gonna try to ping it from here. Ping. It should be successful. So now let's ping the classroom from the instructor PC. I'm gonna copy the IP address again here. Just rinse and repeat, and then I'm gonna ping. It should come successful. So our last test, let's try and ping the tutor from the admin. Let's go to PC, this one, PC7, ping. We need to know the IP address first, so IP config, we know it now, so let's go to the admin. So we already have the IP address, so let's just this one, tutor, PC, okay, ping. Okay, so okay, that is it was successful here as well. So in conclusion, we demonstrated how to use the ping command in Cisco Packet Tracer to verify network connectivity. We tested communication between lab 1 and 2, admin and management PC, classroom, instructor PC, and tutor and admin PC. With that, the pinging demonstration concludes. Thank you.
Today you have Yusuf here to explain for you the servers. So I'll show you all the servers in here. We have 3 servers basically, which is firstly DNS server. Okay, yeah, we have 3 servers in here. First one is FTP. That's here, copy. Then go from lab 2, this PC. Okay, let's check on it. Move from here, put it here. Okay, then access successfully. Then let's go with browser. I'm sorry because my PC is lagging a little bit. Yeah, and let's have access on it. Also PC1 have access on it. Let's go here. Check first. Statics, then automatics, and let's go again. Web browser. Then it have access on it also. And it have access on it. Okay, so the next server is cloud server, which not all the PCs have access on it. So for example, let's go for PC0 and wireless network and see by ourselves. Web browser, then let's see if does it have access on it or not. Okay, because the time is out. So basically, all these three rooms are connected to the same IP address, which is it's not given access for the cloud server or any tutor room. Only the one having access for tutor room are the classrooms. I mean cloud room, cloud website. It should be only the labs and the admins who have access for it. Let's see for ourselves here. Okay, here the students have access on the website and they can see everything fine, but here they don't have access. I think it's still processing. Okay, let's go here to make it faster, then go try to find access on it. And meanwhile, let's see another PC and see if it does have access or not in this classroom, which have only tutors. Okay, let's check on this first, then go again, and the web browser. I don't understand why it's not working here, but I think it's a problem in the, yeah, finally, request time is out. So I think also for this tutor room, they don't have access on it. So basically only the classrooms and the admin server have access on cloud room. Okay, let's see here also to verify that. Okay, requested time is out. Okay, let's close it. Then let's go for based and go. Yeah, it shows you the access. For the last website, which is mmu.edu.my, everyone should have access on it in the whole classroom, in all the classroom. Let's see. Here, for example, paste, go. And it have access on it, show you the home, about, services, and content. Let's see classroom 1. Yeah, everyone have access on it. Laptop, wireless laptop, browser. Yeah, they have access. Here is everything. Thank you.
So now I will be introducing our topologies and our IP and router configurations. So first, we began by designing a logical topology that organizes the network into interconnected segments, and each segment caters to a specific task like Lab 1 and Lab 2, the administrative office, the server rooms. So this logical segmentation allows better management and traffic and resources. As for the physical topology, we mapped out the network's physical layout, including devices, switches, and cabling. Each room in the physical design is equipped with the workstations connected to a central wiring closet, and this ensures accessibility and maintains organized structure, essential for troubleshooting and failover. So as for now, I will be diving into the configuration. So we implemented IPv6 addressing for modem scalable connectivity. We will now discuss the router configuration, beginning with the router labs. So it connects labs 1 and 2. It includes DHCP pools for each lab with assigned prefixes and DNS settings to provide automatic IP addressing. OSPF was configured for efficient routing between the areas as well. Next, we have the router internal. This manages the administrative and server subnets. It features DHCP pools for admin, tutor, and classroom segments. This ensures that it each has a unique addressing. The serial interface and OSPF configurations allow seamless communication with the other routers. Finally, we have the router ISP, which acts like the external gateway, connecting the networks to the external resources. Frame relay encapsulation and OSPF ensure efficient routing for WAN links, WAN links. So now I will be explaining the access control configuration, access control lists. So to enhance the security, we implemented IPv6 ECLS on router internal. These ECLs restrict the access to external resources while allowing specific subnets such as admin and tutor to access critical web services via HTTP and HTTPS. So by applying these filters on the outbound interface, we ensure unauthorized traffic is blocked, protecting sensitive data and network integrity. So that is all for the physical and logical topologies and the configuration of the IP and the router. Thank you.